This lesson is all about how to graph a circle. Let's begin. Plotting a circle on a graph requires two things: a grid reference for the center point and a radius. A circle is the set of all points the same distance from a given point, the circle's center. A radius, r, is the distance from that center point to the circle itself. On a graph, all those points on the circle can be determined and plotted using x and y coordinates. There are two expressions to show how to plot a circle: the center radius form and the general form, where x and y are the coordinates for all the circle's points. H and k represent the center point's x and y values, with r as the radius. The center radius form looks like this: x minus h squared plus y minus k squared equals r squared. The general form, which requires a bit more work than the center radius form to derive and graph, looks like this: x squared plus y squared plus dx plus ey plus f equals 0. In the general form, d, e, and f are given values, like integers that are coefficients of the x and y values. If you are unsure that a suspected formula is the equation needed to graph a circle, you can test it. It must have 4 attributes. 1. The x and y terms must be squared. 2. All terms in the expression must be positive, which squaring the values in parentheses will accomplish. 3. The center point is given as hk, the x and y coordinates. 4. The value for r, or radius, must be given and must be a positive number, which simply makes common sense. You cannot have a negative radius measure. The center radius form gives away a lot of information to the trained eye. By grouping the h value with the x, the form tells you the x-coordinate of the circle's center. The same holds for the k value. It must be the y-coordinate for the center of your circle. Once you figure out the circle's center point coordinates, you can then determine the circle's radius. In the equation, you may not see r squared, but a number, the square root of which is the actual radius. Try these 7 equations to see if you can recognize the center radius form. Feel free to pause the video for more time. Are you ready? Only equations 1, 3, 5, and 6 are center radius forms. The second equation graphs a straight line. The fourth equation is the familiar slope-intercept form. The last equation graphs a parabola. Now, let's look at how to graph a circle. A circle can be thought of as a graphed line that curves in both its x and y values. To get a curve to graph as a circle, you need to change both the x exponent and the y exponent. As soon as you take the square of both x and y values, you get a circle. To plot that for yourself, recall that the value h will be your x-coordinate, and the value k will be your y-coordinate. Together, hk give you the center point. The radius will be the square root of the number on the right side of the equation. Use a calculator to find the square root of that number on the right side and use that as the radius. Whatever the units of measure are in your center radius form, those are the units to use in your graph. This means you may need a graph that is marked off in very small increments like ones or very large units like hundreds. Often the center radius form does not include any reference to measurement units like millimeters, meters, inches, feet, or yards. In that case, just use single grid boxes when counting your radius units. When the center point is the origin 0, 0 of the graph, the center radius form is greatly simplified. X squared plus y squared equals r squared. For example, a circle with a radius of 7 units and a center at 0, 0 looks like this as a formula and a graph. X squared plus y squared equals 49. Next, let's learn how to graph a circle in standard form. If your circle equation is in standard or general form, you must first complete the square and then work it into center radius form. Suppose you have this equation. Rewrite the equation so that all your x terms are in the first parentheses and y terms are in the second. You have isolated the constant to the right and added the values unknown 1 and unknown 2 to both sides. The values unknown 1 and unknown 2 are each the number you need in each group to complete the square. Take the coefficient of x and divide by 2. Square it. That is your new value for unknown 1. Repeat this for the value to be found with the y terms. Replace the unknown values unknown 1 and unknown 2 in the equation with the newly calculated values. And simplify. You now have the center radius form for the graph. You can plug the values in to find this circle with center point -4,3 and a radius of 5.385 units, the square root of 29. That's it. Feel free to review the last section of the article below for cautions to look out for.